there, this is a quick lecture that will be about the morphological trends from early pre-hominid species all the way to us. So this will just give you a broad overview of what you can expect to learn about in more detail until the end of this class. So you should have out in front of you this worksheet, this chart, which we're calling the hominid taxonomy chart. And it breaks down the groupings of the different species and their timelines into 4 main periods. You'll see in the first grouping that you have possible transitional species between ape and human. So we're trying to go back to the very beginnings here and see how long ago we diverged from other ape species. And this category includes Sahelanthropus chadensis, Ornithogensis, and Ardipithecus. The next grouping is called definite transition species between ape and human, and that's because these ones have definitely been confirmed as really being part of our lineage, and you can see that's about 4.2 to 3.2 million years ago. And it includes Australopithecus onamemsis, Australopithecus afarensis, who's more commonly known as Lucy, and Kenyanthropus platyops. And you're going to notice that some of these are highlighted in red. Those ones that are highlighted in red are in our direct lineage, meaning that we evolved from that species. These other ones in black are branch species that are our cousins, but not our direct relatives. The third grouping is the era of hominid diversity, which is a time period in which there were many different kinds of hominids living all over Africa. And so we call it the era of diversity. And that's from about 3.2 to 1.4 million years ago. And that includes gracile grade Australopithecines and robust grade Australopithecines. So you'll see under the gracile grade, Australopithecus africanus and Australopithecus gari. Under the robust grade Australopithecines, we have 2 species names, Australopithecus, or sometimes called Paranthropus aethiopicus, Australopithecus or Paranthropus robustus, Australopithecus or Paranthropus boisei. And again, we'll get into the naming controversies a little bit later. Your last major grouping is the genus Homo, which we trace back to about 2.3 million years ago to us here in the present. And we have Homo habilis, also sometimes called rudolfensis, Homo rudolfensis, Homo erectus, which sometimes is subdivided into Homo ergaster, Homo floresiensis, and Homo georgicus, which probably has been taken off of the list at this point, but we'll talk about that. Homo heidelbergensis, Homo neanderthalensis, and Homo sapiens, which is us. So again, we're going to go into this in much more detail over the next couple weeks, but in the meantime, get familiar with these names. This is another way of looking at the chart. Okay. What you can see here is a timeline that goes back in time, and it shows you, this one here starts with Ardipithecus and Australopithecus onamemsis because these are really the confirmed hominids. And this one shows you the way that the branching seems to be going. Again, this is all based on evidence, and new evidence is always emerging, but there's some important trends I want you to notice here. We've got the early Australopithecines coming around the 4 million year mark, and then they branch off here into this group called Paranthropus. And again, it's either Australopithecus or Paranthropus. We'll talk about that. But we've got 3 species here that we call dead-end species because they branched off and went their own way and then just died out longer ago than 1 million years. In the other direction, we have the genus Homo, and we've got all of these different species that were around quite a long time. And led to us. Now what you're going to notice is we've got Homo heidelbergensis here giving rise to Homo neanderthalensis and Homo sapiens, which means that our direct ancestors, Homo heidelbergensis. Neanderthals are our cousins. We didn't evolve out of Neanderthals. What you can see over here too are when some of these key characteristics arose with the different species. So you can see with bipedalism, that's going to be the key characteristic of anything the hominid. So that's the one thing that is required for a species to be included in the grouping. So again, we've only confirmed that these species are bipeds. You're going to see about 2 million years ago, we see a quick expansion of the brain. And this, of course, is right when the genus Homo appears. So our species here is going to have larger brains on average than others. Cheek tooth reduction means that we're getting smaller teeth, and we're going to talk about the significance of that. Consumption of large animals. Again, about the 2 million year mark. And why consumption of large animals? Well, consumption of large animals requires tools. And so we'll also see these tools arising here, starting at about 2.5 million years ago with the Oldowan tools. We'll see the Acheulean tools, which are more specialized. And then we'll see some of the more detailed tools that appear later on. So now I just want to kind of highlight some of the key morphological trends. That means the shape changes that we've seen happening over time. So as you saw in the previous primate section, we gained evidence of bipedal skeletal structures, and there were 5 key factors that went into that. We saw the foramen magnum is forward. Remember, that means that the hole is right at the base of the skull, so the spine can enter from the bottom. We have an S-shaped spine, which is used to center our balance and hold us upright. We have a bowl-shaped pelvis, which holds our guts and centers our balance. And then we've got our knees kind of angled in, again, centering our balance. And our feet, our toes, are pointing forward here, compared to chimpanzee, which still has this divergent big toe, which is used more like a hand. Also, you're going to notice that over time we are growing taller and beginning to weigh more. This is all relative to our brain size because over time our cranial capacity is expanding. So our bodies have to get bigger to support those big heads. So what the cranial capacity is actually the brain case capacity. So if you have a smaller brain, you have a smaller cranial capacity. And as you can see, as we get to the genus Homo, the cranial capacity expands, as does our body size. These are some key notes that you're going to want to take note of here. These are some vocabulary words that you want to be aware of. So we've got the supraorbital torus. Supra means above, orbits means eyes, torus means ridge. So that's the brow ridge right here. Over time, this big flat brow ridge begins to decrease and divide. And we get this kind of dip in the middle. Over time, a forehead emerges. Here, our earlier species has no forehead whatsoever. It slopes back from the supraorbital torus. We have a forehead that springs straight up out of our eyes, so we have a true forehead. Reduced prognathism. You can see here there's some prognathism, and as you saw with some of the prosimians, there's extreme prognathism, which means a snouty face like a dog. But our faces are very flat. And you're going to start to see over time reduced or post-orbital constriction. So post means behind, orbital means eyes, constriction means pinching in. So this species here, this is actually Lucy, has pinching behind the eyes, meaning that it dents in here behind the eyes. This is a constriction on the brain that we're going to see. Okay, we're going to see more about that in a little bit, but there's pinching behind the eyes here, whereas our brains have expanded to fill in that pinching, so we have this nice round cranium here. A sagittal crest disappears. So the sagittal portion of the cranium is up here, and a crest is this little kind of spiky thing. Now, our species, a few odd species amongst us have it, but for the most part, we don't have any kind of crest on the top of our head. And we're going to talk about what is it for. Now, this is a member of that odd dead-end species I mentioned earlier that's sometimes called Paranthropus. Okay, and so they have this tiny little crest. They also have large zygomatic arches. Zygomatic arches are cheekbones. Now ours are tiny and squinched in, tiny little hole and ridge. This is a wide, huge hole for the zygomatic arches here. And over time they become flatter like ours. Now we think what we see here is that the zygomatic arches, the large zygomatic arches go with that sagittal crest because huge muscle attachment is required here. So these species probably had large chomping and biting and grinding power. You can see how big their teeth were compared to ours. So big biting muscle here came up under the zygomatic arch and attached itself to this crest here at the top. That is a huge muscle. Now ours attaches here and teeny tiny little muscle comes right here, and that's it. Now we think what happened was, and we'll see especially with the primates, there's large, especially with things like gorillas and chimpanzees, they have large zygomatic arches and sagittal crests. Now, over time, we think that there was a mutation that allowed the muscle to shrink back. Now, of course, that means that our muscles are weaker, but that allowed our brains to expand. Rather than to be sort of caged in by those biting muscles, we compensated for our weak jaws with our brains. You also notice the nasal aperture, which is nose opening, is very big on this more ancient species and becomes smaller over time as we move towards Homo sapiens. Last major characteristic I want to talk about are the teeth, and you're going to hear a lot about teeth. So part of the reason that you hear a lot about teeth is because those are the hardest part of the body, and sometimes that's all we find. And so if we find some teeth, we want to know, is this from a species of our lineage or not? So what we see is that over time, our canines become smaller. And remember, our canines are these kind of pointy teeth on the edges. This is another cast of Lucy. So Lucy has smaller canines. They don't hang down. But primates, you'll see, do have long canines that hang down. Other prosimians and catarrhini. However, our canines are relatively short. Ours are even shorter than Lucy's. The diastema also shrinks because the diastema exists for the canine. It makes space for the biting and the cutting of the canine. We're going to see that the teeth get smaller because there's less enamel over time. So you can see the teeth are smaller here and less, ridges and biting. Mental eminence, or the fancy name for a chin, emerges. So you can see here in the chimpanzee, there's no chin. Even in this early Lucy or Australopithecus afarensis, there's no chin. But amongst Homo sapiens, there is a chin. And actually, we're the only ones with a chin. The purpose of the chin is not necessarily all that clear, except for possibly it's the result of a flattening face. But we don't really know why chins emerged. Okay, and then you can see the shape of the dentition changes over time. So we move from this kind of U shape that we find in other primates. So this very nice long jaw, because remember they're prognathic, so they have plenty of room for their teeth to all fit in there. This would be a chimpanzee. This is Lucy, so she's somewhere in between us and them, and you can see that the jaw is starting to flare a little bit, and her face isn't quite as long. But what she does still have is this simian shelf right here where this star is. And that is also going to disappear over time. So by the time we get to Homo sapiens, you're going to see we have this very flared, or what we would call horseshoe dentition, and no simian shelf here. Of course, without the simian shelf, you have a much easier time speaking, and your tongue can move around. It's not attached to this kind of thing here.